Hello and welcome back, friends. We'll start with the part 2 of thin layer chromatography. In previous chapter, we have studied the basic definition of thin layer chromatography, when to use the thin layer chromatography, what are the advantages of thin layer chromatography or the paper chromatography, column chromatography, and other techniques of chromatography. Some basic fundamental, it is a adsorption as well as partition chromatography that we have studied in the previous lecture. Now today we'll start again with the operations which are involved, operation or technique of your thin layer chromatography. So the first step, you studied the various steps involved. That is, first is your selection of stationary phase or adsorbent. So while doing choice of stationary phase, following characters have to be considered. The chemical composition of stationary phase and in a particular that of its surface must be suitable for task like dissolved like. The substance which are soluble in a particular solvent can be separated by using the polar or non-polar solvent. To obtain satisfactory separation efficiency, the main thing is particle size. The particle size distribution and morphology of particle size must be considered. So whatever particles we are using for preparing the thin layer, what is their size and shape, that is important. So how the absorbents are chosen? Two general practices decides the selections are particle size and homogeneity. So generally the particles of 1 to 225 micrometer size are preferred for the purpose. Factor affecting selection are there should not be any reaction with substance to be separated. It should be non-reactive. It should be insoluble with mobile phase and solvent used for elution. So whatever mobile phase you are using, it should not solubilize the stationary phase or the layer. It should not catalyze or decompose of the substance. There should not be any reaction between the substance and your stationary phase. It should be colorless. Many organic substances like charcoal, it is colored one. It cannot be used every time. So silica is a colorless, that is preferred. Should have greater mechanical strength because we are using certain coating process. So it should withstand thickness on the plate. So we'll classify the adsorbent use. So whenever we have been asked to give the various adsorbent use in thin layer chromatography, we had to classify in two ways. First is based on to the bonding strength. It can be classified as weak adsorbent, intermediate adsorbent, and strong adsorbent. Weak adsorbent are examples are sucrose, starch, talc, cellulose. Intermediate adsorbent having the intermediate strong affinity, that is silica gel, calcium carbonate, calcium phosphate, and magnesia. And strong adsorbents are alumina and charcoals. And the second method of classification is based on the nature, whether it is inorganic adsorbent or organic absorbent. So inorganic adsorbents are silica gel, aluminum oxide, kieselguhr, magnesia, magnesium silicate, and organic absorbents are cellulose, charcoal, etc., sucrose, etc. So various stationary phase used in thin layer chromatography, we can write their names as silica gel H, that is silica without binder. Okay, H is hydrated without binder. Silica gel G, that is with gypsum as a binder. Silica gel GF, G stand for gypsum and F stand for fluorescence. So silica gel with gypsums and fluorescent material. We can have the alumina. Various types of aluminas are there: acidic, basic, neutral alumina. So we'll study this in detail also. Aluminum oxides with or without binders, they can be utilized. Or cellulose powder, again with or without binders, we can use this cellulose powder of various categories. So this silica gel generally used is silica gel GF, where G stand for gypsum and F stand for fluorescence indicator. So gypsum or certain binders can be used like zinc silicates for the purpose. Silica gel PF, that is 254 and 366, especially it is P stand for preparative purpose. So thickness is higher, and again it has the fluorescent background which will fluorescent at 254 nanometer and 366 nanometer. Therefore it is silica gel 254 plus 366. Then one is your silica gel HF, that is with number 254. It contains binder and fluorescent indicators. What is silica gel? Silica gel is a granular porous form of silica made synthetically from sodium silicate. Despite the name silica gel, it is solid. It is not having the gel-like structure. Silica gel is used in chromatography as a stationary phase. Due to the silica gel polarity, non-polar compound tends to elute before more ones, hence the name normal phase chromatography. We know that there are two types of chromatography, normal phase chromatography and reverse phase chromatography. In case of normal phase chromatography, your stationary phase is polar and mobile phase is non-polar. If you are directly using silica gel, due to its polar nature, it will be used as a normal phase chromatography. Now certain techniques are available where we can absorb the non-polar group over this silica gel, that is modification of silica gel, and that modified silica gel plates can be used for the reverse phase chromatography where the stationary phase will be non-polar and the mobile phase will be polar. However, when hydrophobic groups such as C18 groups are attached to the silica gel, then polar compounds elute first and method is to be referred as a reverse phase chromatography. You can see the structure of silica gel which is here. So in case of the silica gel, we can see this all OH groups. Okay, so they are responsible for the polar nature of silica and that are responsible for holding the liquid on the surface also, and this polar nature will cause the hydrogen bonding with your sample and differential distributions. Silica gel is also applied to aluminum or plastic sheet for thin layer chromatographic purpose. The second component or adsorbent used is cellulose. It is cellulose C6H10O5 N number of this unit attached together is a long chain polymeric polysaccharide carbohydrate of beta glucose. It absorbs water or alcohol, can be retained by interaction with these hydroxyl groups. Two types of cellulose are used in planar chromatography. Either we go for one, that is polymerization between 400 to 500 glucopyranose unit, or with only 40 to 200 glucopyranose unit. Light and heavy cellulose, these are called. The next component is your alumina. It is aluminum oxide. Alumina is aluminum oxide with the chemical formula Al2O3. It is manufactured in three pH ranges: acidic alumina, basic alumina, neutral alumina for different types of sample. Acidic alumina compounds like phenol, sulfonic acids, carboxylic acids, and amino acids are separated on acidic alumina, whereas the basic compounds as amines, dyes are separated on basic alumina. So neutral compounds such as aldehydes, ketones, and lactones are separated on neutral alumina. So it is available in three categories: aluminum oxide or alumina. Now the next step is preparation of plate, coating on the surface of plate. This silica gel mixture is spread as a thin slurry on an unreactive carrier sheet. Usually, we can choose the glass for this purpose, or thick aluminum foils or plastic can be used as a support for this layer of silica gel. The resultant plate is dried and activated by heating in oven for 30 minutes at 110 degrees centigrade. The thickness of adsorbent layer is typically around 0.1 to 0.25 mm for analytical purpose and around 1 to 2 mm for preparative purpose. These preparative layers are thicker one. Preparative, that is we are interested in separated components. The particle size of adsorbent, again, it is between 1 to 25 micrometers. If you are using simple TLC, it is 20 to 25 micrometers. But if you are going for HPTLC, it is 1 to 5 micrometers, 5 up to only 5 micrometers. Very small particles of uniform shape is used in the HPTLC for increasing their performance. Method for application of adsorbent, we can use the pouring method. The adsorbents of finely divided and homogeneous particle size is made into a slurry and it is poured onto the plate and allowed to flow over it so that it is evenly covered. So this slurry is coated by rotating the plate evenly so that a even layer will be formed on the surface of the plate. The another method is a dipping. This technique is used for small plate by dipping the two plates at a time back to back in a slurry of adsorbent in chloroform or other volatile solvent. We can prepare the slurry in certain volatile adsorbent and directly volatile solvent, and directly we can dip two plates back to back in that slurry so that it will get coated with the adsorbent layer. Exact thickness of layer is not known and evenness of layer may not be good if you are using pouring method or dipping method. Spraying method was also there. Slurry is diluted further for operation of a sprayer, but this technique is not used nowadays as it is difficult to get the uniform layer as well as the clogging of the nozzle of your sprayer. So only the thing which we can use is using spreaders. So spreading technique is used where all above method fails to give thin and uniform layer. Modern method utilizes spreading devices for preparation of uniform thin layer of the glass plate. So commercial spreaders are of two types. One is called as a moving spreader and another is moving plate type. In moving spreader, a uniform thickness of 0.2 to 2 mm is possible. So such type of the spreaders are used with the trough. So this trough will hold the liquid. So we have to rotate this trough so that the trough will be on the surface of plate. So when we passes this trough through the plate, there is a formation of a thin layer on the surface. The distance between this trough and the plate can be adjusted by using this plate knob, and this distance will decide the thickness of your layer which is there in the on the plate. Now the third step, that is sample application, that is called as a spotting. Generally, 2 to 5 microliters of 1% solution of samples or standard is spotted using capillary tube or micropipettes. So a technique is there to make a small tip in the capillary. So just by pulling it onto the flame, so we rotate the capillary, simple glass capillary on the flame, and when it is hot, we pull it in such a way that it will be forming a small thin orifice in the center. Okay, we break the capillary and we use that capillary for purpose of spotting the samples. Standard or test samples are spotted using capillary tubes or micropipette. The spot should be kept at least 2 cm above the base of a plate, and spotting should not be immersed, or the baseline should not be immersed into the mobile phase in a developing chamber. So we are developing, we can mark the baseline initially and on which we can mark the spots, and we also have to mark the solvent front up to which we will run the plates. The area of application should be kept as small as possible for spraying uh, greater resolution. Okay, so you should have a sharper and greater resolutions. So the distance between these two spots should not be more than less than 2 centimeter. So we have to keep this distance 2 centimeter from each other. And when we are spotting, again we have to take care that the spot should not produce any hole onto the plate, because this hole will penetrate the sample through the plate, and when you develop this plate it will not produce the visualization of your spots. So there should not be any hole formation on the plate while we are doing the spotting. Then the next step is choice of solvent, that is mobile phase. Selection of mobile phase depends upon nature of substance to be separated. Again, like dissolved like. Viscosity and polarity of stationary phase is also important. That is the important characters. The solvent used may be a single or double phase system. We can use N-hexane, cyclohexane, carbon tetrachloride, benzene, toluene, trichloroethylene, chloroform, diethyl ether, ethyl acetate, N-butanol, acetone, ethanol, and methanol as your solvent for the purpose according to the increasing polarity. We will stop here and we will again continue in the next part after the break. Thank you and see you soon.